Question 44 is the first instance that you'll look at that may have a residual point that looks a little bit shonky. Now, as we enter the data, we go Calc, Regression, Linear Regression. We select Formula to be copied. We put in the residual and list 3, and then we'll go ahead. Now, write that down. So negative 6.71 is your gradient and 22.42. Now, when you graph that, you'll notice that the points all fit beautifully with one significant exception. That value of 8 kilometres is negative 8.72 below that predicted by the model. Now, I'll just show you how we can look at that at the residuals now. So we get back into the table, we set the graph, but we change the setting to list 3 and hit the OK or the set, and then the graph. Now you can see here I've kept the function on. You can see here we've got a bit of a skewing. We've got almost all our points slightly above and one significantly below. I'll just get into the analysis trace. And something seems a bit odd about this data. You can see there the column figures, and bang, negative 8.72. Now, in a situation like this, the other points look pretty okay. It might be a case, as is in case D, to redraw or replot the data. Now, we can do that relatively easily on our calculator by getting into that. I'm just going to edit the cell. I'll have to do that for all 3. The negative 40. And then I'll just run the data again. I want, once again, the Y1 and the list 3. See here a very strong negative correlation, a very high at 99.87 coefficient determination, and the clincher will be the residual plot. Now, by default got that, and you can see there pretty low magnitude residuals distributed reasonably evenly above and below the axis. That would give us a much more reasonable set of data to work with. I'll just go back in there. We'll get those figures again. Now, if ever this was to appear in a test or an exam, you would be required to do this again. The remodeling or perhaps the flagging of it would be pretty obvious. We would then use that data in order to go through and do parts F, G, and H. And I'll demonstrate that in a moment.